Hi guys, welcome to another video. I'm Charlie from Vermos Gaming. So in this video, I'll be going through my experience of tearing down and applying liquid metal to a Powercolor Red Devil 6800 XT. So going straight to it, let's play this at 2x. So probably will mute this while I commentate over it. So this is a Powercolor 6800 Red Devil XT that has never been dismantled before. So the customer brought it to me saying that it has high temperature issues, and yeah, so wanted me to try and fix it. So I recommended liquid metal as well, because that is the most effective way to bring down the temps, especially in a hot country like Singapore actually. So a lot of you viewers have commented that yeah, so my card even with a regular paste gets the kind of temperatures that I'm posting with liquid metal. But my question is that quite a few of you guys are watching from internationally. So some of you guys are probably maybe in Europe, in Australia, maybe in the US, where ambient temps are pretty different. Like right now, my ambient temperature in my room right now is about 27 degrees Celsius in Singapore, and it is not a very sunny day. It's quite a cloudy day. But on the high end, it can be as high as like 30 degrees Celsius and ambient temps. And then if you have a room that is like open, well ventilated, and if it's like in the hot days of in Singapore, you can hit as high as 31, maybe 32 degrees Celsius ambient temperature. But regularly in indoor rooms without air conditioning, it is probably around 29 to 30 degrees ambient temperature, degrees Celsius. So right now, like just for example, it's 27 degrees Celsius ambient temps, so it's usually on the higher end. And yeah, so it's usually a challenge for us to get lower hotspot and GPU temps in a country like Singapore. So in this case, yep, the standard teardown. So I'll skip through the most of the interesting parts. For teardown, right? Obviously, if you have something like the Gamers Nexus teardown mat or something where you can categorize your screws, that'll be great. But in my experience, even if you have a mat like that, if you don't have something to keep the screws in place, you can very easily knock away the screws from your table. And if it falls to the ground, that's where the nightmare starts. It's like really hard to find a small tiny screw that has fallen to the ground. So what I usually like to use is a magnet. So you can buy any sort of fridge magnets and things like that. And I use those magnets to try and keep my screws in place. And it has helped me pretty well. So right now I can't really like do a teardown without the magnets helping me. So you can see, I will probably pause as in now and then. This is the GPU die. So this is the thermal paste. This is pretty dried up. How you can see it's pretty dried up even from a video replay is that you can see this rectangle that's been formed, and like the excess paste in the corner is like kind of it has formed like a wall, a rectangular wall. So that is a sign that it has dried up. Just by looking at this, you can't really tell whether it has dried up or not. Maybe you can see some signs of paste being super dry. Is that the spots around here, rather than being like liquid gooey consistency, a paste consistency, it looks powdery. So when you dismantle a GPU and then you look at like the thermal paste looks powdery, it's more or less a sign that the thermal paste has completely dried up. So it's time for a repaste. Like for you guys, if you are not staying in the cooler climates like Northern Hemisphere, Japan and up, where your ambient temps is like 20 plus degrees Celsius, good thermal paste will work fine. Personally, thermal paste does work fine for me as well, but I just prefer liquid metal because it's I use very low cost liquid metal from AliExpress, and it really helps me to bring down the GPU hotspots and GPU temps for maximum performance. And basically, for a lot of people that mentioned that no liquid metal, there's risk to it. I have found ways to mitigate that risk by applying the liquid metal really thinly, and also doing insulation around the SMDs around the GPU die. Then, but mainly is how you apply the liquid metal. If you apply the liquid metal really thinly, a thin layer on both the cold plate and the GPU die, usually there isn't as much a risk of spillage. Then if you follow my installation methods where you apply nail varnish on the side of the GPU die where it's covering the SMDs, even if there is spillage, it's generally still quite safe. Your electronics, your GPU will still survive. Okay, so there is the back plate with the LEDs there. And I'll just skip through a little bit more. Yep, so this is the fan shroud. And right now in this teardown, the customer wants a deep clean because he has never dismantled this GPU before. I think it's probably been using the GPU for at least 2 years, maybe 3 years. So right now I'm dismantling the fan shroud as well. And my idea is to dismantle all the GPU fans, remove all the cables, detach the heatsink from the fan shroud, and then to give the heatsink a good thorough wash down. So yeah, washing down the heatsink while all the electronic parts, especially the GPU fans, are removed. I have tried washing it with the did I wash with the GPU fans? Yeah, actually, I did try washing GPU fans once. It wasn't a good experience. So out of 3 fans, one of the fans died, and I had to like purchase a new replacement fan, which is not that expensive. It costs about 20 to 30 SGD if I order it from AliExpress, but it is pretty annoying because it takes about anywhere from 2 to 4 weeks for it to deliver to our place in Singapore. Okay, so this is just most of my bald spot being shown. And yeah, so yeah, I'm trying to take out the fans. So you can see that there are 3 fan screws inside underneath the fan that's like securing the fan to the cooler. So you got to remove that. And it's a little bit hard to access. Oh, right now I'm removing the fan shroud. So in this case, there's 1, 2, 3, 4, I believe 5, 6. There's 6 screws. There's attaching the so-called the plastic fan shroud with its RGB lights to the GPU cooler. So they're located one here, 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 and here. And I'll fast forward some of it through because this is a pretty I do have a lot of videos. So I think I spent an entire day just doing this. That means a good 5 to 6 hours at least. Yep. So now the fan shroud is removed. If we'll just see the point where I remove the fan shroud. So I already removed the screws. The hard part was removing the cables. So you can see that on this model there has some cable guards or something like that kind of like secures or keeps the wire from getting out of position. And those are pretty difficult to remove. So that fan shroud is removed with its RGB LEDs. And then this is the cooler, like the heat sink with the 3 fans attached. So you can see that the center fan is a little bit smaller and the left and right fan is a little bit larger with the Red Devil logo. And as I mentioned earlier, there are 3 screws for securing each fan down to the cooler. So if you notice, I'm using a different piece of magnet. It's because I like to separate out the screws so that I know which screws are for which part of the GPU. Since when you're dismantling a GPU, you can end up with as many as 20 to even 30 screws. So for me, using different magnets is a good way to categorize it. So in this way, this particular magnet is for holding all the fan screws. Fan screws that secure the fan to the cooler. So there's 9 of them, and so I'm removing them. Okay. Yep. Then let's fast forward through. Then right now I am removing the cable. So you can see that the cables is a bit tricky. And actually in the follow-up videos or later in the video, you will see that actually I did damage the fan cables, I believe. Either I did damage the fan cables or the fan cables were originally damaged. I can't be super sure, but the fan operation was a little bit iffy. So in this case, this particular video, right, actually I referenced back to it quite a few times during the reassembly process because I wanted to get the fan orientation correct and the orientation of the fan cables correct. So I clean off the scraped off the dried thermal paste, and then I just sweep it into a dustbin. And these are the 3 fans. You can see how dusty they are on the underside. So these fans have never been cleaned, I believe. And then this is the GPU fan shroud. So you can see that the LEDs there are really dusty. So there's this daughter board. So to say for the RGB LED, so I'm removing the daughter boards because I want to remove all the electronic components, including the RGB LEDs, before I bring it to the bathroom and wash it with water and soap. So notice I'm using a different magnet again, so that I kind of remember that, okay, so for this particular red magnet, these screws are for attaching the RGB LEDs to the plastic fan shroud, which is quite a few of them. So there's this daughter board for the RGB LEDs in the middle, and there is this end part where the Red Devil has that kind of fin LEDs at the end of their fan shroud, which looks pretty cool, but it's actually pretty annoying when you want to clean it, because I have to unscrew at least 4 screws, so there are 4 screws tying it down. So I have to unscrew, wriggle them out. Yeah, and then they're attached to that particular daughter board, which has another header that's attached to a cable that's attached to the PCB. Okay, so teardown is almost done. Okay, then this is the next video. Okay, I want to rotate the video. This one. And rotate. Okay. So this is a simplified clip of me showing like I'm washing down the heatsink. So I wash down the heatsink with water and with soap and used toothbrush as well. So to scrub out like the dirt. Like this is the plastic fan shroud, and below that is like a metal, kind of like a part of the fan shroud as well. So actually this is just a small part of it. I think my camera ran out of juice, ran out of battery, because I did actually wash them down with soap as well. Then after I wash the fan shroud, I actually leave them to dry overnight. Obviously the heatsink and the fan shroud needs to be totally dry before reassembly. And then while I'm leaving them to dry, I work on the other parts of the GPU. So in this case, I am cleaning. Let me speed it up. Wait, I can't speed it up. Oh, I wonder why. Normally I can. Playback speed. Yeah, I don't know why I can't speed up anymore, but oh yeah, I can here. Okay, so let's speed up to 2x. And yeah, so I use a damp cloth and I'm just wiping down the RGB LEDs, cleaning the dust in between, that's wedged in between the fins there. Okay, so I'll skip through that. So it's a bit hard to reach with my fingers, so I use like a tweezer with the damp cloth, just clean it as best as I can. Okay, this one took a fair bit of time. You can see that I dedicate at least like almost a half an hour just to clean up the fins. It is most of the dirt is really hard to reach. So even though it looks really cool, this RGB LEDs really are a pain to clean. I believe this is the second Red Devil card I've cleaned. I have actually deep cleaned a 6900 XT Red Devil before, the Powercolor version, and it has the exact same RGB LEDs, which give me the same headache when I was trying to clean them. Yep. So now I'm like using a cotton bud to try and a damp cotton bud to try and fit in between the fins, try and clean it better. I'm using this blow dryer, so it's a electronic like blow dryer in a way for drying stuff. So it's a high RPM fan, pretty loud, but it's pretty effective. You can buy it from shops like AliExpress and so on. Yep. So it's battery powered. You can just plug it the USB-C, power it. And in this case, wait, I'm already drying the heatsink. Is this the next day? Let me check. What's the day of the recording? Oh yeah, so this is already the next day. I see. So originally I dismantled it on the 12th of January. And this, when I was cleaning the RGB LEDs and taking out this heatsink, it was already the following day. So it has mostly dried. So I'm just using the blow dryer to blow in between the fins to ensure that all the moisture is jettisoned out of the fins, so that they don't get onto the PCB during reassembly. And what's next is I think I do some sanding. Did I was it? Yeah, so I'm sanding like parts of the heatsink. You can see that there are parts of rust here. Yep. So on, even though this is, I believe this should be a copper heatsink if I'm not wrong. The frame should be made of steel. So what I'm doing is that parts of the steel, even though I think it's nickel plated, um, okay. I'm trying to sand in between the fins, but I wasn't very successful because you can see that there's white oxidation in between the heatsink fins. So I was trying to use the sandpaper to sand it, but in my experience, I mean, I try, but it has not been effective. You can see, like, I even used the tweezer to try and scrape out the white oxidation, but it doesn't come out on the tweezer. So it's quite tightly bonded. If anyone knows how you remove the white oxidation from heatsink fins such as these, please do drop me a message or in the comments so that I really like to know. Is it you're using a chemical bath? Can we use any household chemicals like vinegar and stuff to remove them and so on? Okay, next up, then I have I use a dremeling tool with a sanding tip to just sand out the rust from the top of the frame. So you can see that there earlier. So if I were to, like, you can see here there are obvious rust spots. So signs of rust here on the top of the frame. And then after I use that sanding tool, so I'll sand away the rusted parts. So smoothing them out. Yeah, you can see most of the rusted spots are removed. Okay, so further sanding. So I'm just trying to sand out any rust spots that I can see. Yeah, so you can see that before this, there was some rust spots on this particular section. Then sanding them out. So using the dremeling tool, then yeah, so just sanding any rust spots that I can see. I think in the middle as well. Yeah, so last but not least, I work on the middle part to support. So it doesn't look exactly nice because you can see the sanding it makes it look a little bit uneven, but at least it removes the oxidation. So now there's this white oxidation layer like on the front part of the heatsink. I try my best to use the dremeling tool and sandpaper to remove them. Wasn't super successful, but yeah, I just remove as much of it as I can. Okay, then this is the other side of the heatsink. So I flipped it over, then I tried to remove the white oxidation part. Wasn't super successful. I think I changed to using a sandpaper. Yep. Yep. So in this case, gloves are good. I bought a good pair of gloves, non-slip gloves, for cleaning GPUs because I mean a lot of these heat sinks are pretty sharp, especially the fins, and with the rust and all that, it can be quite poisonous if it gets into the blood. So just wear gloves to protect yourself. Okay, then yeah, I try my best to use sandpaper to sand away the remaining rust, but it is really hard to reach with the heat pipes in between. So yeah, so just remove as much of it as I can. So if you have any tips for better removing all this rust, please drop me a message, post in the comments. If you have a video for reference, maybe you can link that video as well so that I can watch and learn. Okay, so I wipe it down, wipe away all the rusted parts, or as in the powdery parts. Then let's forward. Okay, so that is for the derusting part. What's next? Derusting. Okay, so next up is the PCB. Oh, I need to flip this video as well. So let me use media player. Okay. Speed. Okay. So For the PCB, generally I just use a dry brush. So obviously I don't want to short circuit anything on the board. So I just use a dry brush, brush away the dirt that is on the PCB. Yep. So I'm brushing away the dirt on this I believe is the power delivery, the do you call it the VRAM? No, VRMs. Yeah, the VRMs. So brushing the dust from the VRMs. So the rest of the PCB and all that. Stray bits of thermal tape, thermal pads, which it is important to remember where they are, because during the cleaning process, some of them can get dislodged and fall off. So it's important to remember where the tape originally was placed. So I did refer to the video for reference. So in this case, now I'm using isopropyl alcohol. In this case, I have 99% isopropyl alcohol. Spray it a little bit on a cotton bud to try and clean the dirt and the dust off the thermal pads on the VRAM. So just hoping that with a cleaner VRAM pad, they'll have better thermal conductivity. What's interesting to me is that if you look at the size of the thermal pad, actually, like for Powercolor, right, they didn't cut a full size of thermal pads. Like the thermal pads doesn't cover the full VRAM, which I'm kind of perplexed. So I don't know, but the card operates well, so it's like probably, yeah. So you might not need full coverage of the VRAM chips in order to get good thermal conductivity. Seems like probably most of the thermals, most of the heat is concentrated in the center of the VRAM chips. So what Powercolor has done is that actually they save a bit on using thermal pads by cutting smaller size thermal pads and just putting it as in the center of their VRAM chips. I don't really feel that's a good idea. I mean, personally, I just want to cover as much of the VRAM and conduct as much heat as possible. But, well, this still seems to work. Then just cleaning up the rest of the PCB with isopropyl alcohol. Last but not least, I believe I cleaned the GPU die with isopropyl alcohol as well, and to prepare for liquid metal. Okay. Yep. So that is clean. What's next? Okay, next up, I am cleaning the GPU fans. So yes, the GPU fans are dusty. They haven't been cleaned before. So what I do is I just use a damp cloth and just clean this is the underside of the GPU fan. The top side of the GPU fan seems to be decently clean. So I believe the owner has actually used a brush and brushed them before, but the underside of the fans are really dusty because they haven't been dismantled before, and it's pretty hard to reach the underside of the GPU fans. So just use a damp cloth and just make sure you clean off the accumulated dirt, and yeah, just I'll skip through. Yep. So for hard to reach areas, I use a tweezer and the damp cloth to try and reach the spoke of the GPU fans. Okay. So fast forward through. It's a tedious process because all this takes hours. Like even just cleaning the GPU fans, I believe took me like good 20 to 30 minutes. Tedious process. Actually doesn't. This video only took me like 5 minutes. Yeah. 8, 10. No, what's the timer on this? Oh, this video took me like 5 minutes. Is it because I sped up the video? Because I was quite sure that it didn't. Yeah, if I go to 1x, this just take 5 minutes? Oh, yeah, it took me 5 minutes. Okay. I thought I could swear it felt longer. But it just took me 5 minutes to clean the GPU fans. Not too bad. So, GPU fans cleaned. What's next? This one I have to open with this and rotate the video. Play it at 2x. So, fan shroud. If you remember earlier, we washed the plastic fan shroud, so it's dry. Now we need to reassemble the so-called the LED parts back to the fan shroud. So reassembling the daughter board. So remember the screws, I've kept it on this this round red magnet, so that's gonna help. And that, yeah, so I'll just skip through certain versions. Oh, so I also do sand down the screw tops. I don't know whether I will show it here. So basically, screw tops are actually exposed to the elements like yeah, to moisture and so on, so they do rust, the screw tops. So when I see rusty screw tops, I actually sand them down with a piece of sandpaper to make sure that they are, you know, the tops are shiny and as free from rust as I possibly can. Then I screw them in, make sure that the LEDs like are slotted in properly. Yep. Okay, so in this case, I show it to the camera. You can see that the top is really pretty rusted, right? So you can see what a bit of sandpaper does to it. So important to wear gloves here. If you don't have gloves, what it does is that the rust will get into your fingernails and it's pretty hard to clean. Okay, then now you can see that the top is shiny because we sanded it. So the edges of the screw still is a little bit rusty, but it's pretty difficult to sand around the screw. The easiest part is the top part where it's flat. So I just leave the round part of the screw as it is, and yeah, as long as the tops are sanded shiny and no longer rusty, it helps. So it looks, firstly, it looks better, and the less rust it has, the less it will spread. Plus, it also reduces, it also prevents rounding of the screws, because if your screw top is like very rusted, the corrosion eventually spreads into the screw like thread, like, and if the screw threads are like corroded and rusted as well, eventually you will strip the screw. So once the screw is stripped, meaning that the threads are all like rounded and no longer sharp, it's very difficult for you to remove the screw in future tries. So yeah, so just want to make sure that the screw tops, at least by themselves, are not rusted, so to prevent further corrosion on the screw tops. I have actually used things like vinegar before to try and clean away the rust, but to me, the vinegar, the residue vinegar actually makes it rust even more. So I've actually stopped using vinegar. So reassemble the RGB LEDs back in. So slot them in, and then there are 4 screws that secure to the bottom. Here, 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 and here. So same, I sand the tops of the screws before I pop them back in. So you can see I am pretty thorough with this process. Yep, this is another rusted top, screw top. So after sanding on, the sandpaper I'm using is, I believe, about 400 grit, or yeah, 400 or 500 grit. So it's pretty rough. So the rougher sandpaper does work faster. If you want to have a finer finish, you can use like 1000 or 2000 grit, but it is going to be slower to remove like the rust and so on. So I prefer to use sandpaper with a rougher grit. I think 400, 500 grit should be good enough. Like if it's 180 or 50, it's a little bit too rough, but it's still possible. Yep, as long as you remove the rust. Yep, so another rusted top. So you can see that the rust like is going into the screw threads itself. So after sanding, at least the top is shiny. So some of the rust will still be inside the screw thread, but at least we remove the majority of the rust, and it helps, yeah, to grip the cross-tip screwdrivers. Okay, so RGBs assemble into the fan shroud, and yeah, so further cleaning of the fan shroud, like the metal outer shroud, so to say. So for this one, they have this outer metal ring, I believe, with the Powercolor logo on it, that is surrounding the plastic fan shroud. It is purely for aesthetics. It does make it like look a little bit more metallic and nice. And I believe here I reassemble the GPU fans. And this part I stopped the video because I forgot the orientation of the GPU fans. I wanted to make sure that I have the orientation correct, where to route the fan cables. So I actually switched off my recording, and then I referred to my previous videos, my previous recordings when I dismantled the fans in order to see how the fans were arranged, where the fan cables were being routed, and so on. So this is why I stopped the video there. And so this next one is, so speed it up to 2x again. So now I'm reassembling the fans. You can see that the video is no flip the other way. Now I'm in here. In the earlier videos, my hands were down here. So this video is flipped, but it is what it is. Yeah, I can't really. I'm not really sure how to control the aspect ratio and the camera orientation when I like position it for recording from top down. So I'm using my phone for recording. So you can see that I route the cables through. So this is what I saw from when I dismantled the fans. So you have this, the fan at the angled end of the heatsink has two connectors. The fan cables are a little bit on the shorter end. So these two fan cables are connected together and then they plug together into the white connector. So this ending white connector at the tail end of it that goes down into the heatsink will be plugged into the PCB. That's where they get their main power and the PWM signal from the PCB. Okay, so in this case, you can see me trying to squeeze in the fan cable into, or this the white connector into this slot. It was where I think it was how it was when I dismantled it, but it could be this squeezing process that broke some of the fan cables, because after the customer got the GPU back, right, he complained to me that the fans were not spinning. And I did actually get it back, and he was indeed correct. The fans were not spinning. But I did further testing that to show that the fans were working, but maybe the fan cables itself were slightly deteriorated or like disconnected at certain angles. Yep. So now I'm reassembling the fans onto the heatsink and doing the same process. That means I sand the tops of if the screw tops are rusty, I sand them and then I screw them in. Yep. So same, you can see me repeat the process of sanding the screw tops and screwing them in. So there are a total of 9 screws, 3 screws for each fan. Yep. So I'll just fast forward this because we've seen this before. And you can see that this is a pretty long video, right? This takes about 30 minutes. Yeah, so what else did I do? Okay, so after screwing in the fans, then I put in the plastic fan shroud with the RGB LEDs back onto the heatsink. So there's this small fan cable that slots into this part of the heatsink. So it's pretty much a pain to get it through. I have to use tweezers. Make sure the RGB LEDs are in the correct orientation and they fit through. So there are like 6 screws again, 1, 2, 3, 4, 5, 6 screws that tie down this plastic fan shroud onto the heatsink. So I'm trying to make sure that they sit properly into align to the holes on the heatsink before I screw them. And same, like the screw tops are rusty as well, so I'm like sanding them before reassembly. And this is a pretty tedious process. So this process alone of reassembling the fans onto the cooler and reassembling the fan shroud already took me 30 minutes. Yeah, so the sanding of the screws is also pretty tedious as well. I think after that, when did I put in the metal part? Wait, yeah. So this part is still the plastic fan shroud. I think I put in the metal fan shroud right in the middle here. Yes, so you can see that this is the metal fan shroud. Yeah, so it's just a metal like outer shell that just makes it look aesthetically nicer. It gives the GPU a metallic outer frame look, but it's actually just it's just an aesthetic piece. And then there are 4 screws that tie down to it. So the screws are obviously, screw tops are rusty as well. So sanded them to make them shiny. Yep, now they're shiny. Now screw them in. Yep, pretty hard for the camera to catch it. And we'll screw them in. So there are 4 screws, I believe, here, Oh, there are 6. So you can see 3 here. 1, 2, 3 if I'm not wrong. So there are 6 screws. So 3 on each side. Okay, so I'll skip through this. This just reassembly. Oh, it doesn't have the Powercolor logo. It has the Radeon logo. So the Radeon. Yeah, it has the Radeon logo. So 3 on each side. So screw them in. Make sure that they're flush. And I believe the fan shroud is assembled. So next part, I connect the PCB to the backplate. So on the backplate, there's a RGB LED with a daughter board and a wire that connects to the back of the PCB. I wasn't sure where this thermal pad is located. Yeah, I believe this should be correct. It should be located on this particular IC chip. So on the underside of the PCB, there is a connector that connects to that ribbon cable there that powers the RGB LED on the backplate. So just wiping the backplate clean. I did not wash this backplate because there's electronics on it and I didn't want to remove it. I believe it's glued down. So I just wiped it clean instead. Yep. So you can see that there's a ribbon cable. It connects to like a white connector on the back part. Yeah, I'm removing the tape because it will fall out anyway. Like certain parts of the tape that's not so secure. Because I'm gonna, yeah, so you can see that there's a white connector here. Then this ribbon cable from the back plate goes into this white connection here. It is pretty difficult to attach, so I remove my gloves here so that I can have better feel and dexterity. Like, okay, so that fits back. Ribbon cable is in. Another ribbon cable from the back that is for to be connected to the RGBs from the fan shroud. Yeah, so RGBs are a pain with so many ribbon cables. Yep. So screwing in the back plate, there are a few screws which screws in the PCB. So on the PCB side, there are a few key screws. I believe there's a total of 5 if I'm counting them correctly. Yep. Then meanwhile, I saw that the IO shield was a little bit rusty. So even though it doesn't look that nice, I just sanded out the rust. So sand out the corroded parts. But it does make the IO shield doesn't look as pretty because it gives it a very washed out look. But yeah, I personally prefer that than having no rust and corrosion sit on the metal parts. And this one is because I sanded the inner ports as well because I remembered the HDMI port wasn't working so well. So what I did was I sprayed isopropyl alcohol and I sand the insides of the ports to remove as much corrosion as I can from the inside of the display port and HDMI ports. In my experience, sometimes this helps it, sometimes it doesn't, but there's no harm in doing it in my experience. So usually it only helps. Yep, try and dry it out. What else? So I continue finishing screwing in the PCB to the back plate. Making sure that the switch is on, I think, OC. Because there's OC and silent BIOS. What else? So put back the thermal pads on this. I believe this is the VRMs. And yeah, there are other thermal pads on the chips. Finally, we get to applying liquid metal. So, took us a long while, but at least we're close to applying liquid metal. So this deep cleaning this GPU took me 2 days. Yep. So, deep cleaning this GPU, the disassembly, teardown, the teardown, deep cleaning, and then the reassembly and reapplying of liquid metal. This GPU took me 2 whole days. The first day was just a disassembly so that I can wash them. Then I have to leave them to dry overnight, and then the reassembly on the following day. So now just this reassembly process is taking me a few hours because it's a few hours worth of video footage. So now I'm applying liquid metal. I'm using the cheap, I think no brand, there's no particular brand. AliExpress just sells them as liquid metal. They don't have any particular brand to it. So it's like from the OEM manufacturer. Right, so I'm cleaning it with 99% isopropyl alcohol. Then, as you can see here, I'm using transparent nail varnish to insulate the surrounding SMDs around the GPU die. I'm not too sure whether this process is essential, but so far it does help because in my experience, I have actually seen spillage of liquid metal from the GPU die to the surrounding like PCB area and to the surrounding SMD areas. So at least to me, this insulation of nail varnish at least protects those surrounding SMDs or the contact pads there to be shorted by prevent them from being shorted by the liquid metal. So I apply generous amounts of nail polish around. Obviously, you don't want to have the nail polish go onto the GPU die. If you do accidentally drip nail polish onto the GPU die, just quickly clean it off with like isopropyl alcohol. You should be fine. And if the nail varnish, you can also let the nail varnish dry up, and then after it dries out, it becomes like a kind of like a hard consistency, right? Like a plasticky consistency. Then you can just scrape it off with like a plastic or a plastic scraping tool or a toothpick. Right, so I've applied nail varnish on it and I'm waiting for that to dry. Then meanwhile, I'm cleaning up the cold plate part of the heatsink and then applying liquid metal on it. My liquid metal is about 1 year old, so it's a little bit hard. So it's a bit hard to squeeze, but it still works. So you can see that I'm struggling to squeeze it out because a lot of it has kind of firmed up, solidified, dried up. But when the liquid metal does come out, it still does work. So just a few droplets of it will do. Then the skillful part here and the experience part here comes in how you're going to spread out as thinly as possible. You can see that it's just a few droplets, right? But that few droplets is actually enough to cover this whole surface. The key is spreading out as evenly as possible. So how you're going to do that is use the tip, a clean cotton bud tip, and you just want to keep dragging them out. So you want to drag them out sideways. Then for the parts that you find that there's like exposed hotspots, the liquid metal will accumulate on the top part of the cotton bud. So you use that accumulated liquid metal to do like a dabbing motion as if you are dabbing with paint to try and cover those blind spots. Okay, so I'll just fast skip through a little bit. You can see that yes, it's actually spreading out. This one I'm measuring the distance between the VRAM and the GPU die because I'm not too sure how far my liquid metal should cover on the cold plate. And here I actually top up a little bit more droplets of liquid metal because it is, apparently not enough. So to push the liquid metal a little bit towards the top, because that from my measurements with the vernier caliper, that is where this cold plate should be contacting the GPU die. Okay, so you can see me measure again the width. So from here, this is where the VRAM is supposed to be cooled to here. So I extend the liquid metal a little bit more. So you can see me doing that dragging motion. So I'm like dragging the liquid metal from the center towards the sides. Yeah, so that's how you spread it out without adding even more liquid metal. So it's still the same amount of liquid metal throughout the patch, but you just, from the areas where there's a little bit more concentrated, you just drag out the liquid metal towards the side to try and spread out as evenly as possible. The more evenly or the more evenly or thinly the liquid metal is spread, the less likely it is to spill. If you have liquid metal that is too much or pulled together in like a flowing pool, then it is definitely more likely to spill and cause damage to your electronics. So the safe method of applying liquid metal is to make sure that the liquid metal application is as thin, as even as possible. As thin as possible, basically. That will make it as safe as possible. So I believe I am more or less satisfied. Yeah, I'm just cleaning out the parts. Oh, okay. So how to clean up excess liquid metal? So in this case, I found that I have a little bit of excess on this side. So what I did to clean was that I sprayed isopropyl alcohol on another clean cotton bud, and when it has isopropyl alcohol, the cotton bud will tend to absorb liquid metal. So if you want to clean up excess liquid metal, then just spray some isopropyl alcohol on a clean cotton bud, then use that soaked cotton bud to try and absorb parts of the liquid metal away. Okay, so here I'm just double checking whether the dimensions are correct. Should be more or less satisfied. So I'm satisfied with my application on the cold plate. Then now I'm applying it on the GPU die itself. So earlier the nail varnish has probably dried up. Then yeah, so now trying to squeeze droplets of liquid metal onto it and using the same technique. So now I use another clean cotton bud and try and spread out the liquid metal again. Okay, so as I forward through, you can see that I try to drag it from the center to the edges. In this case, I think it's probably not enough. So I try to top up with maybe one droplet of liquid metal. Then I spread out further out. Yep, so most of it is covered by my hands. But you can see in this particular motion, you see I'm dragging it out, right? Dragging out from the center to the edges, so that dragging out to areas where there's insufficient liquid metal. And then the parts where it's a little bit exposed, you will see me doing some dabbing motion, where I dab those exposed parts with the tip of the cotton bud, because the tip of the cotton bud is soaked in liquid metal. So I dab that soaked liquid metal onto the exposed parts to cover them. Okay. So here I bring it closer to the camera, I believe, for close-up. Yeah. Yeah, so I don't know how much we can see from here because my hand is blocking most of it. Yeah. Okay. Okay, this part is slightly better. Okay, so maybe I'll just rewind this. So you can see I use a lot of dragging motion, and then there's a certain part that's exposed, right? Because as you can maybe this part I'll just slow it down to 1x speed. Okay, so you can see that as I drag, this part was exposed. See, when I drag, okay, so when I drag through, this certain part is exposed. There's less liquid metal. So what I do, right there. So after I drag, yeah, because right now liquid metal is pretty thin, right, and not as flowy. Yeah, so you can see that this part is exposed. So what I do to cover this exposed part is I use the dabbing technique that I mentioned earlier, where I dab with the tip of the cotton bud that's soaked in liquid metal to dab on these exposed areas here. Yep, and then I'm also drawing more liquid metal from the other ends, like from the sides where there's more, to drag it into those exposed areas. Where the die is exposed. Yep. Then you can see me do a lot of dabbing, like touching and dabbing. Yep. So those dabbing, that dabbing motion, dab, 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 to make sure that all the exposed parts of the die are covered. Yep, then you can see me moving the liquid metal around, make sure dabbing. Yep, you can see the insulated layer here is a little bit shiny because that's the solidified nail varnish. I'll fast forward through. So I believe this is a pretty even coverage of liquid metal. is even and thin because as you see, as I tilt the GPU, you don't see any pools of liquid metal floating around. So it means that the spread of liquid metal is sufficiently thin that you will stay in place. But you also do not see any like obviously exposed parts. So if I rewind that a little bit, so as we go through here, maybe slow it down. Yep, you can see that all the GPU die is evenly covered. There's no obvious like exposed parts, like any part of the GPU die that's exposed, that's not covered by liquid metal, but yet the liquid metal is not thick enough that it's flowing. So a sign that there's too much liquid metal is if you see a pool of liquid metal, if you tilt the device, your liquid metal is flowing to one side. That is a little bit too much. So if you have too much liquid metal, you can follow the advice I mentioned earlier. Just spray some isopropyl alcohol into one of your clean cotton tips and then use that soaked cotton bud to pick up and soak up some of the liquid metal away, because liquid metal seems to be attracted to isopropyl alcohol, and then the cotton bud soaked in isopropyl alcohol tends to pick up and absorb some liquid metal. It doesn't pick up all of them, but it picks up some. So there is a way of removing it if you have excess liquid metal. Okay, so this is I consider this a pretty good even application. Okay, then I'll speed it up back to 2x speed. Okay, I believe next will be the reassembly. So reconnect the fan cables to the PCB. That is the RGB cable from the back of the backplate to the fan shroud. So that controls the RGB LEDs, makes them a uniform color. Okay, then reassembly. And then I believe I screw them in. Yep. Yep, so remember that I categorize the screws via magnets. So this is one of the magnets where I have all the screws for the GPU backplate. Then same thing again, where I find that the screw tops are a bit rusty, I sand them down to a shine. And this part is not super interesting, so I'll just forward through. And I wipe it clean, just wipe the back parts clean, just ensure that there isn't any liquid metal that's on the outside surface. And benchmarking. Okay, so this is the benchmarking process. And yeah, so I think let me fast forward through. This is how many minutes? 5 minutes, 3 minutes of benchmarking. And can we zoom in? No, this is just a subtitle text. But wait, can we view? I don't think we can zoom. Can I zoom in using other viewing tools? Let's check. What if using a media player? Video settings, zoom to fill. Yeah, there's not much of a zoom. Yeah, I can't zoom in on a particular section, but I believe we can still see, even though it's rather zoomed out. So this is the end of the benchmark test. I run Unigine Heaven benchmark because it's a very simple test. I ran it on my M-ATX case, so it's inside a small Lianli Dan A3 M-ATX case to show that the temps while it's inside a case. So in this case, the average GPU temps is about 69. Oh, nice. 68. Maximum is 69, so average is 68. Or current is 68. Sorry, average is 56 because it started from the minimum whereby it's idle. So it's not, I don't really follow the average here. You can do a more correct average where you reset the readings after the GPU has warmed up. That means the benchmark has started for like 30 seconds to 1 minute. Then you reset the temps, then you get a better average temps of it under load. So I would say that the average temps is probably around 68. The memory junction temps is 72. So like I mentioned, even though the thermal pad is located in the center of the the VRAM chips, it still works, right? To keep the VRAMs nice and cool. VRDDC, I think this is the voltage rail. This is the important one. GPU hotspot is averaging at 83. The peak is also at 83 right now. So 83 is considered pretty decently low for my room, which has an ambient temp, I believe, then of about 26, 27 degrees Celsius. Yeah, so fan speed is at 1200. The maximum is 1300. So pretty low RPM. I've seen some GPU fans that can ramp up to like 3000 RPM. So usually on the 3000 series cards, like the 3080s, 3090s, they can really ramp up really fast to try and keep their GPUs cool, because those because of that, yeah, the 3000 series has issues with temperature, because they struggle with heat dissipation, especially their very hot GDDR6X VRAM chips. So pretty good, right? So it's spinning and all. Yeah, so the fan works well. So this is the end of the teardown, right? So everything done, return it to the customer. Customer should be happy, right? With the, yeah. But the other part of the story is that after the customer brought it home, they found that the fan is not spinning, and then no matter how much he put the GPU on load, the fan didn't spin. So that was the issue. I wasn't complete with my servicing yet. And yeah, so when I tested it, you can see that in my video, the fan was spinning when I tested it. But when the customer brought it home, it didn't work. So we met up the next day, and I collected it back, brought it back to my test bench, and indeed now it's powered on. You can see the LEDs are on. MSI Afterburner is running, and you can see that I have set up the MSI Afterburner fan speed to 55%. GPU clock is currently 0 because it's idling. Yeah, but the fans are not spinning. Right, as you can see in this is hardware info, HW info. It says GPU fan RPM at 0. Yep, it is idling, so it's not the temps are pretty low because there's no load. It's just in the desktop, but you can see that the fans are not spinning, so that is an issue. So what I did was to try and further diagnose whether there's a problem with the fans. Was that I did a voltage injector. So this is, the fans are spinning here. So what I did was I dismantled the heatsink from the fan shroud again to try and test whether there's any issue with the fans. So in order to isolate it, I actually did a voltage injection. So what I did was, if you go back to here, this part, obviously the electronics, the wires are pretty narrow, right? Pretty hard to access. I can't access it using crocodile clips. So I have the live clamped on to this just a sewing needle. This sewing needle is, I believe, connected to the yellow wire that is for voltage power, that means connected to the red. And then the ground cable is a black one that's connected to this needle that's connected to the black crocodile clip that connects to earth or ground. So when I inject voltage, the fan spin, and you can see that here I have about 4 volts, right? Yeah, so it's about 4.6 volts. The fans are spinning, and when I increase the voltage, can I have maybe some volume here? So I increase the voltage to about 8 volts. Wait. Okay, let's hear that. Try and hear that again. So this is the fan spinning at 4 volt. So increasing voltage to 8 volts. Okay, it's subtle, but the fan should spin louder. Wait, do I have recording? Yeah, do I have desktop? Yeah, desktop audio should be on. So the fans actually spun louder. So I'm showing the customer that with a voltage injector, actually the fans are working. So there's nothing wrong with the fans. So the issue is probably has to do with the fan cable, the wires itself. So my suspicion is that during assembly, if we look at the fan cables here, you can see that there's a lot of warping and twisting of the fan cables here as well as here, right? So my suspicion is that I might have like torn some copper inside the fan cables, and then that resulted in inconsistent operation. So here everything works. Then when I reassemble it, it was spinning on boot, right? Then when I YouTube video was saying, yeah, when I tested it, fan cables were spinning. Let's see. Yep. So now I run it in MSI Afterburner. Right, it's fans are running at 1004. I believe I set it to 44% fan speed. It is in the desktop on idle. There's no load, but you can see that, yeah, fans are spinning now. And then I also did benchmarks, I believe, right, in the MATX case, whereby if you see here, fans are spinning at 1230. Then hotspots are okay, decent, 83. So GPU average time is 69, nice. And yeah, so on and so forth. Then here it's pretty hard to see because it's invisible because the fans are here. So the fans are actually spinning. You can see a little bit of motion there. So I repeat. Yeah, you can see a little bit of motion. So that's a sign that the fans are actually in motion and spinning. Right. So fans were spinning, and yeah, so this took me like the next day. So I returned it to the customer on the 15th of January again. And recently, like I haven't met the customer yet, but the customer has complained again that the fans still stopped spinning again. He tried wiggling the fan cables around, it didn't work, the fans still stopped spinning. So what I'm gonna do is have the customer bring this GPU back to me, then dismantle, take a look at the model number of the GPU, and order a set of replacement fans from AliExpress. Then hopefully the replacement fans, it will solve everything. And while the customer is waiting for like 2 to 4 weeks for the fans to be delivered, I'm gonna just lend one of my existing 6800 non-XT 6800 non-XT GPUs. It's a little bit low end GPU, but at least it's a replacement for him to use it within that 2 to 4 weeks. Because I do feel responsible for damaging the fan cables, because probably his fans were working fine before he brought it to me. So somehow during my disassembly process, I destroyed his fan cables. So there is that, and that will be the end of this video. It's been pretty long, so you can see that this teardown video reassembly takes a long time. This is about how many days? 12, 13, 14, 15, 4 days worth of videos compiled in one single one. Okay, so if you guys like more of this hardware content, primarily in this channel I try and upload my GPU adventures, so my GPU cleaning, my computer hardware adventures. And if you'd like to see more of those content, yep, stay subscribed, because I have actually just deep clean my own custom water loop PC, and I already have videos on it. So I'm probably gonna do a long commentary video on the 5 days that I spent trying to deep clean my hardline water cooled PC, from disassembly to cleaning to deep cleaning to reassembly to refilling the water to testing it, and so on and so forth. So I have videos of that coming up. So if you are interested, please stay subscribed. We will see you guys in the next one.